So we might have at least mentioned this before, but square roots are always positive. So you see square root of 4, type in your calculator, you're going to get the answer, which is positive 2. We don't really consider square roots to ever have anything other than a positive answer. However, this is a little different question here on the right. This is saying x squared is equal to 4. So you're squaring some number to equal a positive number. Well, when you square a negative, it also equals a positive number. So there's two possible answers for this. You probably already know the two answers, 2 and negative 2. So when it's in this form, what we do to both sides, if you show your work, you're taking the square root of both sides. When you take the square root of both sides, make sure you put plus or minus on one side. You have to remember to do that. So this would be x, because x squared, it undoes the x squared. It gives you just x when you take the second root or square root of a perfect square. So x equals plus or minus 2. So that's really two different answers. So that represents x is 2 and x is negative 2. It's fine to write it just like that. So I didn't mention this, but whenever the root is even, this is how you do it. You put the plus or minus. So when it's even, so when this root is even, so that's like a 2 there. So when it's an even root, when it's even, then you put plus or minus every single time. When you take the second root or fourth root or sixth root of each side, any even root of both sides, you do that. Odd roots work a little differently. So odd roots can be negative, so that's not a problem. Even roots are always positive, right? We said that. So odd roots can be negative. In fact, the answer to this one, if you type in your calculator, is negative 2, because negative 2 times negative 2 times negative 2 is in fact negative 8, or sorry, negative 2 is in fact negative 8, because we have three negatives. The first two negatives maybe make a positive, but this one still makes a negative. So it's quite possible to have an odd root of a negative and get a negative answer. There's no imaginary. If you take the even root of a negative, you're going to get an imaginary answer, but there's no imaginaries here. These are real answers. They can be positive or negative depending on what you're taking the cube root or fifth root or seventh root of any odd root. So when you take the cube root of both sides, very similar here, take the cube root of both sides, I don't have to worry about plus or minus because this one's negative. I know I'm going to get a negative here. So I don't have to worry about plus or minus. There's not going to be two different possibilities here whenever it's an odd root. So the formal property, if you want to write it down in your notes, is this. The nth root of b to the n is b. If n is odd, the nth root of b to the n is positive, or the absolute value of b. That's a way of saying this is positive if n is even. The square roots are always even. So if you had something like the fourth root of, I'll just say negative 2 to the fourth, the answer is 2. It's got to be positive, right? Even though the fourth root, if you think about order of operations, what you would do in this problem, you would actually multiply that out. You get 16. Negative 2 times negative 2 times negative 2 times negative 2. Fourth root of 16 is positive 2. So if you do order of operations, you'll see that that actually works, but that's always true. The absolute value for even roots is always positive there. Okay, so typically when you're solving a problem like this, if you don't happen to know the fourth root of 16, I wouldn't really expect you to know that. Then I would get out, just kind of start doing a factor tree. So 2 times 8, 2 times 4, 2 times 2. The numbers at the end of the factor tree are all prime here. So this is equal to, if you want to write it differently, the fourth root of 2 to the fourth. This is a much easier problem to solve. Fourth root of 2 to the fourth, it's an even root, so I know it's positive, and it's just going to be 2, because you're undoing what's the opposite of putting something in the fourth power? You're putting it to the fourth root. So you're looking for 4 things the same. You have 4 things the same, so it's just 2. I say you could use factor in your calculator. What I mean by that is this. So if you got your calculator out, you can do a prime. I will allow you to do prime factorization of a number. No problem here. So if you want to do a factor to get there, menu, number factor, and factor 16, it will give you the prime factorization, which is 2 to the fourth. So it just saves you the time of doing the factor tree there. So that's not a problem for me. So this one, you could think about it in two separate or a couple different separate things here. So I'm going to write this differently. I'm going to say that's the fourth root. I'm going to break this up into x to the fourth times. I'm just going to break this up. And I see a group of two. I'm looking for four of anything, right? Because I've got fourth root. So I see two groups of four. So I'm going to break that up into this way. So one way of doing this is to go, well, the fourth root of x to the fourth is x. Fourth root of y is y. Fourth root of y to the fourth is y. So we get x times y squared would be our answer there. So it might be helpful to think in fractional exponents. So I don't know if we've mentioned this before, but this is the index or root out here, the n out there to the left of the radical. This m is the exponent. And so when you have a fractional exponent that, like a rational exponent, this is called, you can write it like that. So in other words, if you saw something like 8 to the 2/3 power, that is the same thing as, if I write that in radical form using this, the denominator is the index here. So this would be the third root of 8 to the, and you can put the 2 here. I usually put the 2 on the outside. It makes more sense in this case to put it on the outside, but you could also put it, so this could be written the mth root of a all to the power of n. That's another way to write. Those two are the same thing. So I usually prefer to write the exponent on the outside because it's almost always to your advantage to do the inside first, do the root first. Keeps the number really small. I don't have to square 8 and then take the cube root. I want to keep the number small. So cube root of 8 is, what is the cube root of 8? So cube root of 8, what times what is 8? That was 2. 2 squared is 4. The answer is 4 here. So you can evaluate things very quickly if you know how to do that way. So let's look at a couple of these. Okay, so let's rewrite these at least in the other form. And maybe it'd be easier to solve them that way potentially. So I'm going to rewrite this in fractional exponent form or rational exponent form. So this is 6 divided by 3, which is 5 squared, which is 25. Makes it easier, doesn't it? Third root of fifth is 6. The other way of doing that, by the way, is to actually break it up, right? You could do third root of 5 to the third times cube root of 5 to the third. Cube root of 5 to the third is 5. 5 times 5 is 25. There's different ways of thinking about this problem, but it might be easier to think about it in rational exponent form. Let's try it on this one. So in rational exponent form, this would be 3 to the power of 20 over 4. 3 to the fifth. I'm not going to bother to do 3 to the fifth. I know 3 to the third is 27. 3 to the fourth is 81. 81 times 3 is 243. I think I will bother to do it. Okay, 243. But I would actually, if you don't have a calculator here, I'd be fine with that answer. And so then you could break that up into 5 groups of 4. So fourth root of 3 to the fourth times fourth root of 3 to the fourth times etc. times 5 times. And so it'd be 3 times 3 times 3 times 3 times 3. This one, the index out here is not written, but it's understood to be a 2. When it's a square root, the index is a 2. So writing that in rational exponent form, that would be 8 over 2, which is 7 to the fourth. And kind of like before, I'm fine with leaving it like that. If you don't have a calculator, if you have a calculator, type it in, see what you get. But I want to see this work. I want to see you do that. Or you could break it up into, I guess, 4 groups of square root of 7 squared, or square root of 49, 4 times. This one, again, I'm going to rewrite it. So in rational exponent form, this is x to the 12 fourths times y to the 16 fourths. So this is x to the third times y to the fourth. Pay really close attention to the roots. So anytime you have, like this is third root, I'm looking for 3 of anything. The first thing I might consider doing is doing the prime factorization of each one of those numbers. So you can type out the word factor, or again, grab it, menu to factor. Factor 27, just going to do positive 27. And then factor 216 is 2 cubed times 3 cubed. So I'm going to write it in its prime factored form here. So this is, first of all, I'm going to rewrite this as a fraction. So this is cube root of, let's see, this one said 27 is 3 to the third, but technically this is still negative 3 to the third because of the negative there. And now this is cube root of 2 to the third times cube root of 3 to the third, because I'm just breaking that up into 2 different groups so you can see the answer is a little easier. The cube root of negative 3 to the third, it's fine for a cube root to be negative, so that's just fine as negative 3. In fact, I knew the answer was going to be negative as soon as you saw the problem. Cube root of negative is always going to be negative. Cube root of 2 to the third is 2. Cube root of 3 to the third is 3. So that you get negative 3 over 6, which is, or you cancel out the 3's, and you get negative 1/2. Simplified form. Same thing here. Let's do prime factorization of this. So let's go menu, number factor of 81, in case you don't know that one, factor 256. Okay, so I'm going to write those in their prime factored form in the numerator and denominator. So this would be fourth root. This is fourth root. Pay attention to what the root is. I'm looking for 4 of something. 3 to the fourth in the numerator, and fourth root of 2 to the 8th. I'm going to write it this way this time. So 2 to the 8th. And see, I'll show you just another way of doing that. The numerator is obviously 3. The fourth root of 3 to the fourth is 3. I'm going to write it as a fractional exponent. So 2 to the what power? This would be 8/4, which is 3 over 2 squared, which is 3/4. So you can do it, get there different ways, kind of solve it different ways. Oh, this is kind of a weird one with a decimal point. I think there's a couple of homework problems like that, so I wanted you to see one like that. So let's just factor 81. Well, we just did, whoops. We just did factor, if you look at your calculator, you factor 81 as 3 to the fourth, but this is 0.81. So let's see, let's try something here. So is that the same thing as 0.3 to the fourth? Not quite. But 3 to the fourth is that. So we could think of that as, but that is that 0.9 squared? 0.9 squared. 0.9 times 0.9 is that. Since we're only looking for a square root, we know the square root of 81 is 9. I mean, you knew that one before I did anything in the calculator. So the square root of 0.81 is 0.9. So, and it's going to be positive. So 0.9 times x to the what fractional power here. So again, this is the second root or square root. So this would be 6 over 2 power. So this is 0.9 or 0.9 times x to the third. This one, let's do the prime factorization of 32. So factor factor 32 to the fifth. So this is fifth root. I'm just going to rewrite this as 2 to the fifth times a to the 10th. So let's break that down. Fifth root of 2 to the fifth is 2 times a to the what fractional power? This would be 10 over 5, which is 2 times a squared. It's kind of a neat, when you get good at just kind of like simplifying, radicals by knowing how to do, change it to exponent form makes it so much easier. Again, you could have broken that down into fifth root of So another way of doing this, after you get, I'm just talking about the a part. So this would be fifth root of 2 to the fifth times fifth root of a to the fifth times fifth root of a to the fifth. So you could break it down like that, and then take the square or the fifth root of each term. So 2 times a, which is 2a squared. You get the same answer. I did it that way. I think it's a little easier when you use the fractional exponents. The rational exponents are a great way to go there. Okay, I think that's your lesson for today.